Hello everyone, this is Abhishek Mohanty and you are watching Padarth Vigyan. So students, in this lecture we'll start a new chapter and the chapter name is vectors. Vector is a very important topic, very important chapter from physics point of view, because to solve many numericals we need to use the vector algebra. So in this chapter we'll discuss about what is the meaning of vector, what is the laws of vector addition and different mathematical operations related to vector. So today is the first lecture of this chapter, so let's get started. So students, in the chapter units and measurement we had discussed that based on the origin, the physical quantities can be classified into two categories: fundamental quantity and derived quantity. The quantities which don't take the help of other quantities to express themselves, or the physical quantities which are self-expressible, are known as fundamental quantities. And we have total 7 fundamental quantities. These are mass, length, time, temperature, electric current, amount of substance and luminous intensity. And if you exclude these 7 fundamental quantities, all other quantities are known as derived quantity, because they need the help of these 7 fundamental quantities to express themselves. Means they cannot express themselves on their own. They need the help of the fundamental quantities to express themselves. But we can also classify the physical quantities into two categories based on whether they have direction or not. So physical quantities can be classified into two categories: scalars and vectors. So what is the meaning of scalar? What is the meaning of vector? Let us discuss about that. So what is scalar? The physical quantities which have only magnitude and no direction are called scalars. So there are many physical quantities which have only magnitude but they don't have any direction. They are known as scalars. For example, mass, length, time, volume, density, work, energy, power, etc., etc. So these quantities, they have only magnitude. They don't have any kind of direction. If I ask you what is the mass of this pen, suppose the mass of this pen is 10 gram, then our answer will be the mass of the pen is 10 gram, and 10 gram is the magnitude. We are not assigning any kind of direction to mass. That's why mass is scalar quantity. And a scalar quantity can be specified by a single number with a proper unit. For example, the mass of this pen is 10 gram. The mass of the pen is 10 gram. Then 10 is the number and gram is the proper unit to measure mass. Similarly, length. Suppose I'll ask you what is the length of this board. Suppose the length of the board is 5 feet. Suppose the length of the board is 5 feet. Then 5 is the number and feet is the proper unit to measure length. Similarly, suppose a time interval is 10 seconds. Second is the proper unit to measure time and 10 is the number. So all the scalar quantities can be specified by a number with a proper unit. Is that clear? But what is the meaning of vector? The physical quantities which have both magnitude and direction. Magnitude thibo au direction madhe thibo. And the third condition is they should obey the laws of vector addition. They should obey the laws of vector addition. So three conditions are necessary for a physical quantity to be a vector. The first one is it should have magnitude, it should have direction, and it should obey the laws of vector addition. Students, remember that when we add scalars, we add them like normal numbers like the ordinary algebra or arithmetic. For example, suppose मैं कही भी 5 kg plus 7 kg. I am adding two masses. Mass is a scalar quantity and I am adding two masses 5 kg plus 7 kg. It will be equal to 12 kg. आमे normal number को जेमिति add करूचे like that we are adding two scalar quantities. 5 second plus 10 second is equal to 15 second. Time is also a scalar quantity. So when we are adding two times, we are adding them like normal numbers. 5 second plus 10 second is equal to 15 second. तार माने स्केलर को ऐड करबा पई आमे नॉर्मल अलजेब्रा यूज करथौ. But remember that when you want to add two vectors, you cannot use the normal algebra. Vector को ऐड करबा पई we have to use some special operation, some special formula. ताके में कहिबा laws of vector addition. And how to add two vectors? What are the different laws of vector addition? We'll discuss about that in the upcoming classes. But for now, remember that vectors cannot be added like scalars or like normal numbers. We must use vector algebra or laws of vector addition to add different vectors. So the physical quantities which have both magnitude and direction and obey the laws of vector addition are called vectors. जदि गोटे फिजिकल क्वांटिटी रो मैग्नीट्यूड अच्छी डायरेक्शन अच्छी बट से वेक्टर अलजेब्रा को ओबे करू नहीं, देन दैट इज नॉट ए वेक्टर क्वांटिटी. फॉर एग्जांपल इलेक्ट्रिक करंट आमे जानिचे सपोज वी हैव ए रेजिस्टर एंड वी हैव ए बैटरी. सपोज 5 ohm is the resistance and 10 volt is the battery. आमे जानिचे जे इलेक्ट्रिक करंट always flows from higher to lower potential in the wire. It means the electric current has magnitude as well as direction from higher to lower potential. Suppose I want to add two currents, 2 ampere plus 6 ampere, 2 ampere plus 6 ampere. The answer will be 8 ampere. The answer will be 8 ampere. ता माने आमे करंट को नॉर्मल अलजेब्रा रूल रे आमे ताको ऐड करूचे. We are not using any kind of vector algebra to add currents, but electric current has magnitude and direction, but it does not obey vector algebra or it does not obey the laws of vector addition, and that's why electric current is not a vector quantity. So remember that a physical quantity can be a vector quantity if it has direction, magnitude, and it should obey the laws of vector addition. And a vector quantity is specified by a number with proper unit and direction. ता माने स्केलर को स्पेसिफाई करिया पई we need a number with proper unit, but to specify vectors we need a number, proper unit and direction. Three quantities are needed: number, unit, direction. Number, unit, direction. But to represent scalar only we require number and unit. Is that clear? So what are the examples of vector quantities? Displacement, velocity, acceleration, momentum, force, etc., etc. So these are the examples of vector quantities. Means they have both magnitude and direction. आमे क्लास 9th रे पढ़ीचे जे displacement is a vector quantity, distance is a scalar quantity, because displacement has some direction but distance has no direction. Is that clear? Similarly, velocity has direction but speed has no direction. That's why velocity is a vector quantity, speed is a scalar quantity. Acceleration, force, momentum, all these quantities are vectors because they have direction. Now I have written the differences between scalar and vector. The first point is scalars have only magnitude. They don't have any direction, but vectors have both magnitude and direction. The scalars can be added according to normal algebra. आमे जेते बेले different scalars को add करूचे, we are following the normal algebraic formula. आमे जेमती नंबर को ऐड करंती ठीक से भली आमे स्केलर को ऐड करि परिबा बट टू ऐड वेक्टर्स वी हैव टू फॉलो द लॉज ऑफ वेक्टर एडिशन the vectors can be added as per the laws of vector addition we cannot add vectors using the normal algebraic operations next one scalars change if their magnitude change जदि आम गोटे स्केलर रो मैग्नीट्यूड को चेंज करिबा देन से क्वांटिटी टा चेंज हो जिवो बट टू चेंज वेक्टर आइदर यू कैन चेंज द मैग्नीट्यूड और यू कैन चेंज द डायरेक्शन और यू कैन चेंज बोथ ऑफ देम स्केलर को चेंज करिया पई वी नीड टू चेंज ओनली द मैग्नीट्यूड बिकॉज इट हैज ओनली मैग्नीट्यूड नो डायरेक्शन बट टू चेंज वेक्टर वी कैन चेंज इट by changing the magnitude or by changing the direction or by changing both. For example, suppose I will consider displacement vector. I will consider displacement vector. Suppose a particle or a person starts from the point O. He moves 5 meters towards east. This is east direction. This is west direction, this is north, this is south. Suppose a person A starts from the point O and he moves 5 meters towards east. The second person starts from the same point and he moves 7 meters towards east. So here the two displacement vectors have the same direction, that is towards east, but the first displacement vector has magnitude 5 meter and the second displacement vector has magnitude 7 meter. So these two displacements are different. They are not same. They are not equal. 5 meter towards east is different from 7 meter towards east. So here by changing the magnitude we have changed the vector. Suppose assume that a third person moves the same 5 meter but along the north direction. A third person C moves a distance of 5 meter in a straight line along north. So what is the displacement? 5 meter towards north, 5 meter towards north. So 5 meter towards north, 5 meter towards east. They have same magnitude but they have different directions. So 5 meter towards east is different from 5 meter towards north. So here I have kept the magnitude same but I have changed the direction. So by changing the direction you can change the vector quantity or by changing both of them. Suppose a person starts from this point O and he moves suppose 7 meter towards west. So 5 meter towards north, 7 meter towards west, they have different magnitude, different direction. So they are different vector quantities. So remember that to change a vector quantity, we can do it in 3 ways. Either you change the magnitude or you change the direction or you change both of them. Then the vector quantity will be changed. Now we will discuss how to represent a vector in figure, in diagram, how to represent a vector. A vector quantity can be represented by a straight line with an arrowhead. Let me write here. A vector quantity or a vector can be represented by a straight line with an arrowhead. So the length of that straight line represents the magnitude of the vector and the arrowhead, the arrow mark, represents the direction. The length of the straight line, represents the magnitude represents the magnitude and the arrowhead represents the direction of the vector. तामाने गोटे वेक्टर को डायग्राम रे बा फिगर रे रिप्रेजेंट करिया पई आमे हेल्प नबा गोटे स्ट्रेट लाइन रो एंड से स्ट्रेट लाइन रो गोटे एंड रे आमे गोटे एरो हेड मार्क दबा लाइक दिस ए स्ट्रेट लाइन with an arrowhead. The arrowhead can be at this end or it can be at this end depending on the direction of the vector. कहीं की ना ए arrowhead रो मीनिंग कौन? The arrowhead represents the direction and the length of the line represents the magnitude. We know that a vector has magnitude and direction. तो आमे जो फिगर रे बा डायग्राम रे शो करिबा वेक्टर को यूजिंग ए स्ट्रेट लाइन विथ एन एरोहेड से स्ट्रेट लाइन रो लेंथ रिप्रेजेंट करिबो मैग्नीट्यूड ऑफ द वेक्टर एंड द एरोहेड विल रिप्रेजेंट द डायरेक्शन. फॉर एग्जांपल सपोज मैं कहिबी ए कार has velocity 40 kilometer per hour along north. A car has velocity 40 kilometer per hour along north. So this 40 kilometer per hour is the magnitude of the velocity and the direction is towards north. Is that clear? And the velocity is a vector quantity. Now we will represent the vector using the symbol. Okay, so 40 km per hour को आमे केमते शो करिबा गोटे स्ट्रेट लाइन नबा एंड से स्ट्रेट लाइन रो गोटे एंड रे आमे एरो मार्क दबा. ओके, एंड रिमेंबर दैट द डायरेक्शन इज टुवर्ड्स नॉर्थ. सो दिस इज नॉर्थ डायरेक्शन, दिस इज साउथ डायरेक्शन, दिस इज ईस्ट डायरेक्शन एंड दिस इज वेस्ट डायरेक्शन. ओके, suppose 40 km per hour, this is the magnitude and the magnitude is given by the length. तो आमे बे कोन करिबा गोटे प्रॉपर स्केलिंग यूज करिबा. स्केलिंग रो मीनिंग कोन? आमे देखिचे इंडिया रो मैप हो किबा गोटे स्टेट रो मैप हो किबा गोटे वर्ल्ड मैप हो. वर्ल्ड इज a very large area but आमे गोटे छोटो मैप रे we are able to see the whole world, all the countries, all the cities in a small space. How is it possible? आमे जो ग्लोब यूज करूचे के मैप यूज करूचे गोटे बहुत बड़ा कंट्री हो किबा गोटे बहुत बड़ा कंटिनेंट किबा गोटे बहुत बड़ा स्टेट तार डिफरेंट पार्ट्स को आमे शो करि पारुचे इन ए स्मॉल फिगर. हाउ इज इट पॉसिबल? यूजिंग ए स्केलिंग, प्रॉपर स्केलिंग. सपोज मु अज्यूम करिबी जे 1 सेंटीमीटर length is equivalent to 10 किलोमीटर पर आवर. ता माने जदि मु 1 सेंटीमीटर गोटे लाइन ड्रॉ करिबी से 1 सेंटीमीटर लाइन रो मीनिंग कोन हबो ना 10 किलोमीटर पर आवर. ठीक अछि, because I have to express or I have to represent 40 kilometer per hour. I have to represent 40 kilometer per hour. तो गोटे छोटा फिगर रे 40 किलोमीटर पर आवर को मु केमिति शो करेबी ना यूजिंग ए स्केलिंग इफेक्ट. तो जदि मु 1 सेंटीमीटर को एज्यूम करिबी एज 10 किलोमीटर पर आवर देन 4 सेंटीमीटर लेंथ विल बी 40 किलोमीटर पर आवर. Yes or no? If I choose 1 centimeter as 10 kilometer per hour, then 4 cm length will be equivalent to 40 kilometer per hour. तब माने मु एबे जो वेक्टर टा ड्रॉ करिबी, जो लाइन ड्रॉ करिबी से लाइन रो लेंथ मु केते नेबी 4 सेंटीमीटर. But if you want you can take 1 centimeter as 5 kilometer per hour. तमे जदि स्केलिंग यूज करिचो लाइक दिस 1 सेंटीमीटर इज इक्विवेलेंट टू 5 किलोमीटर पर आवर देन 40 किलोमीटर पर आवर पाई लाइन रो लेंथ केते आसीबो 8 सेंटीमीटर. 8 सेंटीमीटर विल बी इक्वल टू 40 किलोमीटर पर आवर. Is that clear? So according to our scaling, we have to draw the length of the line. Suppose I'll use this scaling 4 cm length रो गोटे लाइन ड्रॉ करी तो से लाइन टा मु एमती ड्रॉ करी पारे किंबा 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 एमती ड्रॉ करी पारे मो इच्छा बट वी हैव टू आल्सो लुक एट द डायरेक्शन गोटे वेक्टर ड्रॉ करिया पई वी हैव टू कीप इन माइंड द मैग्नीट्यूड एज वेल एज डायरेक्शन आमे मन इच्छा जे कोनसी डायरेक्शन रे वेक्टर को ड्रॉ करि परिबा नाही प्रत्येक वेक्टर रो किछि किछि डायरेक्शन थाए तो स्पेसिफिक डायरेक्शन जो थिबो आमे सेही डायरेक्शन रे आमे वेक्टर को ड्रॉ करिबा एंड द डायरेक्शन इज टुवर्ड्स नॉर्थ सेते पई द लाइन विल बी लाइक दिस 4 cm लाइन ड्रॉ कली एंड द एरो मार्क विल बी हियर जदि मो एरो मार्क एमे देबी तारा मीनिंग कोन हबो द डायरेक्शन इज टुवर्ड्स साउथ the velocity is towards south but in the question it is given that the velocity is towards north and that's why the arrowhead should be towards north. Is that clear? So this vector represents a velocity of 40 km/h. Is that clear? So this is how you can represent a vector quantity. So now we'll discuss about different types of vectors. So now we'll discuss about two types of vectors. The first one is position vector, the second one is displacement vector. So what is the meaning of position vector? Suppose I will draw a plane. This is a plane, this is the x-axis, this is the y-axis. Eta hauchi gote xy plane. So this one will be the origin O. O is the origin. The position vector ro meaning kon? Suppose a point P is located here. A point P is located here. So a point P ro position vector meaning kon? So the position is measured with respect to the origin. The position of a point or of a particle or of a body is measured with respect to the origin. So this is the origin. तो आमे कोन करिबा आमे ए पॉइंट रो बा ए पार्टिकुलर पोजीशन को डिटरमाइन करिबा with respect to this origin and for that we have to join this point with the origin. आमे कोन करिबा गोटे लाइन ड्रॉ करिबा that line will join the point P with the origin. So the line will be like this, okay, and we have to give a arrow mark because every vector has some length and some arrow mark. तो arrow mark टा केमत रहिबो arrow mark तो डायरेक्शन रहिबो from origin towards the point, from origin towards the point. So this one is the position vector of the point P. So position vector means the vector which joins the origin with the point and directed from the origin towards the point. So let me write here position vector of a point is a vector which connects the point with the origin and is directed from origin towards the point, This is the meaning of position vector. Now we'll talk about displacement vector. Displacement vector ra meaning kon? So displacement ra meaning kon? If the particle changes its position, then it will be displaced. Again I will draw the xy plane. Suppose this is the x-axis, this is the y-axis. So we have xy plane. Suppose initially the particle was at point P. and this is the origin. So when the particle was at point P, the position vector was this one. This was the position vector. Now after some time, the particle will be at a new position Q, at a new position Q. Now the position vector will be changed. Now this is the new position vector. And when the position vector of a particle changes, the particle is said to be displaced. So initially the particle was at the point P, and after some time the particle is found to be at the point Q. So the displacement vector will be a straight line joining initial point with the final point, and it is directed from the initial to the final point. Displacement vector is a vector which joins the initial point with the final point of the particle, and it is directed from the initial point to the final point. Is that clear? So this is all about position vector and the displacement vector. Now we will talk about what is the meaning of polar vector and axial vector. So students, polar vector means a vector having some point of action. A vector having some point of action. Polar vector. Polar vector means a vector having some point of action. For example, force. Suppose I have a body here and I apply a force at this point. The force is a vector quantity, and when we apply force on a body, the force is applied at a specific point on the body. So जो vector रो कोटे specific point of action थाए ताको हमें कहिबा polar vector. So force is the example of a polar vector. Similarly, velocity is also a polar vector. Displacement is also a polar vector. Is that clear? So any vector having a point of action are known as polar vector. But what is the meaning of axial vector? What is the meaning of axial vector? Axial vector meaning. First let me write the definition of the polar vector here. A vector having a starting point or a point of application is known as a polar vector. Example कौन आसिबो? Displacement, velocity, acceleration, force, etc. These are the examples of polar vectors. But what is the meaning of axial vector? Axial vector means the vectors which act along the axis of rotation. And remember that the axial vectors are associated with a turning effect, a rotational effect. For example, torque, angular momentum, these are the examples of rotational vector or the axial vector. तो हमें अपकमिंग क्लासेस में किसी सब्जेक्ट की चैप्टर अच्छी जो चैप्टर रे हमें डिस्कस करिबा व्हाट इज द मीनिंग ऑफ एक्सियल वेक्टर लाइक टॉर्क, एंगुलर मोमेंटम. So these vectors, they act along the axis of rotation and they don't have a starting point, but they act along the axis of rotation. Suppose a body is rotating in this circular path, the angular momentum will act along the axis of rotation. Is that clear? So आमे ए विषय future class रे पढ़िबा about angular momentum, what is about torque. Okay, but for now remember that axial vector means the vectors which act along the axis of rotation, and they represent some rotational effect, some turning effect. Is that clear? So this is the difference between polar vector and axial vector. Next class रे हमें discuss करिबा some definitions used in vector like equal vectors, collinear vectors, negative of a vector, unit vector, zero or null vector. So that's all for today's class. Hopefully you have understood all the topics that we have covered in this video. So in the next class we'll proceed further. Till then, have a nice day and bye bye.